Hi, this is Mrs. Ward, and this is section 5.3, solving trigonomic equations. So what you should have with you right now is you should have the 5.3 solving trig equation note sheet, and this video is going to follow along with that note sheet. So if you need to pause the video, just go ahead and pause the video, and let's get going. So when we're solving trig equations, we're going to have three basic types of situations. One type is going to be when I have one type of trig function with one x. So an example of that would be tangent of x plus the square root of 3 is equal to 0. My one trig function is the tangent function, and then that this tangent of x only appears in one term. The second thing that can happen is I can have one kind of trig function, but more than one x. An example of that would be if I had 2 sine squared x minus sine x minus 1 is equal to 0. My one trig function is going to be the sine of x, but I have x in two places, two terms, one here and one here. Cannot combine those to make those a single term, so that would make it a different way of solving this equation. And the last thing that can happen is I can have more than one trig function. So if I have cosine of x times a cosine squared x minus 2, I have two separate different trig functions. One would be the cotangent, one would be the cosine. Another example would be if I had sine squared x minus 3 cosine squared x is equal to 0. Again, two different trig functions. I have the sine of x and I have the cosine of x, two different trig functions. So hopefully you have your unit circle memorized. If not, get your unit circle out or your trig chart, whatever's going to help you follow along. So the first one, and we've done these types of problems before back in chapter 4, and we did a little bit when we started inverses, but if I have the sine of x is equal to 1, I'm asking you to look on your unit circle or look on your trig chart, and it's asking you when is your y value equal to -1. And I'm going to come up with 270 degrees if I do degrees, or I prefer radians, 3 pi over 2. And some of you from the last section could also be thinking negative pi over 2. Any one of those answers is acceptable. They all represent the same place. They're all coterminal angles. They're representing the exact same location. But what's a little bit different about this section is this is saying find all the solutions. There's going to be two types of directions that we have today. One is going to say find all the solutions, and then one is going to say find in a certain interval. If it says all the solutions, it means it wants all the answers going forward as I go into higher and higher numbers. In other words, more than one lap around the unit circle. So the easiest way to do it, and I'm going to pick probably the most common answer, which would have been 3 pi over 2, is I'm going to take 3 pi over 2, and I'm just going to add, I'm going to tell the person that I want to add laps around the unit circle. In order to do that, I'm going to write 2n pi. And this 2n pi, what that means, this means laps around the unit circle. So I can take as many laps around the unit circle as I want, and those laps will always be an answer to this equation. So let's look at the next one. The next one is the tangent of x is equal to 1 over the square root of 3. You probably don't have it written like that, but when we solve, we may have it written like that. You probably have, since this is 1 over the square root of 3, you probably have the square root of 3 over 3. Those are the same thing. One's rationalized, one is not. So this is asking when is the tangent equal to the square root of 3 over 3? And if I look at my unit circle, I'm doing sine over cosine, and I end up with pi over 6. That's one place where the tangent is equal to a positive square root of 3 over 3. But there are two places on the unit circle where the tangent is equal to a positive number. One is in the first quadrant, and that's this one here. And the other one's in the third quadrant, and that would be 7 pi over 6. So that would be one lap around the unit circle, 7 pi over 6 and pi over 6. But if I want to continue forward and do multiple, I'm going to add these laps around the unit circle. So I'm going to write plus 2n pi plus 2n pi. Ooh, that looks really messy. 2n pi. And that means I'm doing laps around the unit circle. When you're looking in the back of the book, when you have tangent, especially, since the distance between those 2 points is exactly one, the distance between here and here is 1 pi, you may also see pi over 6 plus n pi, which just means they're going to do one lap around the unit circle, because if I add pi, I'll get 7 pi over 6, add another pi, and that'll be that 2 pi. So either one of these are fine. The last one is I have to do a little work for it. I have this 2 sine of x is equal to the square root of 2. So when I go to solve that, first thing I'm going to do is I want to put my trig function on one side by itself. So I'm going to divide both sides by 2. So let's show me dividing both sides by 2. And when I do that, I have the sine of x is equal to the square root of 2 over 2. So when is the sine of x equal to the square root of 2 over 2? Well, one place in the first quadrant would be pi over 4. And the next place that the sign is positive is in the second quadrant, and that would be 3 pi over 4. If I want to do all my solutions, I'm going to add those multiples of 2 pi. So 2n pi plus 2n pi, and that gives me all my solutions. I cannot just add pi, because if I add pi to pi over 4, that would be 5 pi over 4, and that does not work in this situation because these two are not 1 pi apart. They are not halfway around the unit circle from each other. So now let's get to our first situation. Our first situation is we're going to solve a trig function where I only have one trig function and I only have one x. So that was the example that I gave you, is the tangent of x plus the square root of 3 is equal to 0. To solve this, I'm going to do basic algebra. I'm going to isolate my variable on one side. So I'm going to isolate tangent of x on one side. In order to do that, I'd have to subtract the square root of 3 from both sides. So I'm going to have the tangent of x is equal to negative square root of 3. Then I'm looking on my unit circle. I'm asking myself, when is the tangent equal to a negative square root of 3? And I come up with that. That happens when x is equal to, and that will be pi, not pi over 3, 2 pi over 3, because it's negative. And the next time that the tangent would be negative would be in the fourth quadrant, which would be 5 pi over 3. Once I pick this denominator of 3, that denominator is going to stay the same. Now this is tangent. The distance between 2 pi over 3, this is in the second quadrant, and 5 pi over 3, this is in the fourth quadrant. They are 1 pi apart. So I can do my answer in two ways, since it's saying find all the solutions. I can do 2 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. That's one way I can give my answer. Or I can just say 2 pi over 3 plus multiples of pi. Oopsie. Multiples of pi, because the distance between 2 pi over 3 and 5 pi over 3 is 1 pi. Either one of those answers is exactly the same. Both are correct. Now the next one gives us an interval. This is saying find all the solutions on the interval from 0 to 2 pi. And this is actually a typo. I think it's right on your sheet. This should be a parenthesis here, because I'm only going to go from 0 to 2 pi. I don't necessarily have to write 2 pi again. Notice that I have one trig function, but you're going to say, hey, wait a second, Mrs. Ward, there's a sine of x here and there's a sine of x here. Well, in order to simplify this, I'm going to have to put the variable on one side. So in this case, my variable is going to be sine of x. So I'm going to add sine of x here, add sine of x here. And when I do that, I'm going to have 1 sine of x, 2 sine of x. 2 sine of x is equal to, minus the square root of 2 is equal to 0. Add the square root of 2 to both sides, square root of 2, and then finally the sine of x is equal to the square root of 2 over 2. And this is the exact same situation we ran into back here. If you remember, I can go back. That's the same situation that we ran into back here, where the sine of x was equal to the square root of 2 over 2. And I gave the answers of pi over 4 and 3 pi over 4. Those are still going to be the same problem, basically. I just had to work a little bit. So I'm going to say pi over 4 and 3 pi over 4. Oh, I said 4 and then I wrote 3. I wonder why I did that. Well, we'll fix that. Caught my mistake. So this is over 4. Now, when we do this, since it wants just this interval, and you'll see here that has the interval of 0 to 2 pi, that means I'm only doing one lap around the unit circle. I don't have to add those additional laps around the unit circle, so my answer is going to say just the pi over 4 and 3 pi over 4. There's no need to write the multiples of 2 pi laps around the circle. Okay, now I have this other one here for you. This one is in a box. I would like you to try and solve it on your own. My hint to you is isolate the variable on one side. So you're going to isolate cosine squared on one side by itself. So you're going to have to take care of this 1 and then take care of this 4. So I'd like you to pause the video, let everyone have a chance to work on it. And then when you guys are ready, start the video back up again. Okay, welcome back. What you should have is the first thing I did is I added 1 to both sides of the equation and got 4 cosine squared x is equal to 1. Then I divided both sides by 4 and got cosine squared x is equal to 1/4. Took the square root, and when I take the square root of 1 is 1, the square root of 4 is 2. Notice that when I take the square root, it's plus or minus. So my cosine is actually equal to 2 different things. One is it's equal to cosine of x is equal to positive 1/2. One is the cosine of x is equal to negative 1/2. The cosine of x is equal to positive 1/2 of pi over 3 and 5 pi over 3. The cosine of x is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. And then I want to go up here and check and see how it says find all solutions. So as soon as I see it says all solutions, that word all there, I'm going to have to add multiples of 2 pi to all of these. So I'm going to say pi over 3. You know what we're going to do? We're going to do pi over 3. I'm going to just list them all, and I'm going to do them in order because that makes more sense to me. And then we're just going to write plus 2n pi at the end. So I'll know that you know that I'm going to add 2 pi to each one of those. So this is a recap. This is when the situation is when we have one trig function. So I only had cosine x in this function, and I only had the x in one term. So that's the first situation. The second situation is when I have one trig function, but the x is in more than one place. So there I have steps on your note sheets. What you're going to do is you're going to see if you can factor anything out. If it's quadratic, you're going to set it equal to 0. And then you're going to list all your possible solutions after you factor. So here, the first one in here, I have 3 tangent cubed x is equal to tangent of x. So I'm tempted to divide by tangent of x, but I really can't do that, so I'm not going to do that. What I am going to do is I'm going to subtract tangent of x from both sides. So I'm going to have 3 tangent cubed x minus tangent of x is equal to 0. Then I'm going to look for greatest common factor. I have tangent of x in this term, tangent of x in this term. So I'm going to factor out a tangent of x. So I'm factoring out a tangent of x. And when I factor out a tangent of x, what I'm basically doing is I am dividing both of these terms. I'm dividing this term by tangent of x. I'm dividing this term by tangent of x. And the tangent of x I'm dividing by is what I put here. What I'm left with when I do that is I'm left with the 3 in this term here. And then when these two, the 3 and the 1, will simplify the tangent squared. And then tangent of x divided by tangent of x will be minus 1. And this is equal to 0. Now I have two things multiplied by each other is equal to 0. So I'm going to use, I don't know if you remember it, the zero product property, which means I'm going to set each factor equal to 0. So I'm going to set tangent of x equal to 0. Tangent of x is equal to 0. And then this 3 tangent squared x minus 1 equal to 0. This one, all I'm going to have to do is list when the tangent is equal to 0. So when the sine is equal to 0 and the cosine is equal to 1, and that will be 0, pi, and then 2 pi, And it only wants the interval from 0 to 2 pi, so that's good. Don't have to write anything else. This one I'm going to have to work for a little bit. So I'm going to add 1 to both sides. So I'm going to say 3 tangent square root x is equal to 1. Add a 1 to both sides. Going up here for more room. Divide both sides by 3. Tangent squared x is equal to 1/3. Then to solve that, I'm going to have to take the square root of both sides. Square root, square root. So this will be the tangent of x. It's equal to plus or minus, because when I take the square, it's plus or minus. The square root of 1 is 1. The square root of 3 is the square root of 3. And I can leave it like that, or I can rewrite it as the square root of 3 over 3. But this is an intermediate step, so I don't have to rationalize at this point. Then I'm going to ask myself, when is the tangent equal to 1 over the square root of 3? So that is going to be, well, it's going to be a positive 1/3. Tangent of x is equal to a positive 1 over the square root of 3 at pi over 6 and 5 pi over 6. And the tangent of x is equal to a negative 1 over the square root of 3 at negative, this is 7 pi over 6, my bad. And this is 5 pi over 6 and 11 pi over 6. So when I write, so these would be all my solutions, all of these. So these here and these here, those are all my solutions. Let's try another one. So this one's saying find all the solutions over the interval, and I still have one trig function. I have 3 terms. I cannot factor anything out because sine of x is not in this one, which means I am going to have to do product sum. That's my only other thing I can do. So my product is 2 times -1, which is -2. My sum is -1, so I'm going to end up doing -2 and a positive 1. So I'm going to rewrite this as 2 sine squared x minus 2 sine x plus sine x minus 1 is equal to 0. From the first 2 terms, I can factor out a 2 sine x, and I'm left with sine x minus 1. From these last two terms, there's nothing I can factor out, so I'm going to write a plus 1 to remind me that I do have something out there, and then write sine of x minus 1 is equal to 0. These two are what I have in common, so when I factor those out, I'm going to have sine of x minus 1 times 2 sine x plus 1 is equal to 0. To find my 0, set each one of these equal to 0. So sine of x minus 1 is equal to 0. 2 sine of x, oh, that looks really messy, sorry, is equal, plus 1 is equal to 0. Here, I'm going to have the sine of x, gosh, I have that, is equal to 1. Here, I'm going to have 2 sine x is equal to -1. Divide both sides by 2. Sine of x is equal to -1/2. Asking myself, when is the sine of x equal to a positive 1? And I am going, that's sine, a positive 1, and that is going to be a pi over 2. When is the sine of x equal to a -1/2? That's going to be 7 pi over 6 and 11 pi over 6. Going back up here to check my interval, it just wants on one lap around the unit circle. So these 3 values are my answer. Okay, try this. Oh, I can't have you do this one on your own. This one's really hard. So let's do this together. I'll start it. No, it's fine. You could be able to do it. Maybe not. Let's see. All right, let me help you out first of all. I have sine to the fourth and sine squared. I have a greatest common factor that I can factor out. The greatest common factor that I can factor out is sine squared. So I'm going to factor out sine squared x, and I'm going to be left with 4 sine squared x minus 3 is equal to 0. Okay, I did the hard part. Now pause the video and try and finish the rest on your own. Set both of these equal to 0. This sine squared x and this 4 sine squared x minus 3. Okay, welcome back. Welcome back. What you should have is, once I have this and I can't factor anything else out, I have two products. I have this times this is equal to 0. I set the sine squared x equal to 0. Here, there's nothing left to do. There's nothing added or subtracted or multiplied by the sine squared, so I took the square root of both sides. So I'm going to get the sine of x is technically equal to plus or minus 0, but that doesn't make sense. It's just 0. So when is the sine of x equal to 0? That happens at 0, pi, and 2 pi. On the other side, I took the 4 sine squared x minus 3 is equal to 0. Trying to isolate the sine squared on one side, I added 3 to both sides. Then I divided by 4. And then I take the square root. When I take the square root, I take the square root of the numerator. Square root of 3 is the square root of 3. Square root of 4 is 2. Since I took the square root, it's equal to plus or minus the square root of 3 over 2. Then I ask myself all the places on one lap around the unit circle, because again, this is just one lap around the unit circle. One lap around the unit circle when the sine is equal to square root of 3 over 2. Those are going to be my radians with a denominator of 3. So then I listed my pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So my solution for this one is going to be these 3 answers and all 4 of these answers. So I'm going to have 7 answers all together, and those are my 7 answers. Okay, and the last type is when we're going to have more than one trig equation at the same time. So when I look at this, this is the first one that I showed you, is I'm going to have cotangent of x, cosine squared of x is equal to 2 cotangent of x. And at first that looks really complicated and really hard, but what I'm going to do is I'm going to put everything on one side of the equation, see if I can factor anything out, and then see if I can replace things and write it in one trig function. So going very, very slow, let's start off very, very slow, and I am going to move that cotangent to the other side. So I'm going to subtract 2 cotangent from both sides. I don't know where to put that. So I'm going to have cotangent of x times the cosine squared of x minus 2 cotangent of x is equal to 0. Then I notice that I have a cotangent here and a cotangent here. So I'm going to factor out a cotangent. Remember, I showed you how to factor out a cotangent if you get confused. I'm just going to pretend like I'm dividing both parts of this by cotangent. So cotangent here, cotangent here. That's what I'm factoring out, is that cotangent of x. From the first term, these cotangents will simplify, and I'm left with cosine squared x. Here's that minus sign. Here, these cotangents will simplify, and I'm left with 2 is equal to 0. I have this times this is equal to 0, so I don't have to replace. I'm good. I can set cotangent equal to 0, cotangent of x is equal to 0, and then I can write cosine squared x minus 2 is equal to 0. When I'm working on the left side, I'm asking myself, when is the cotangent equal to 0? Remember, cotangent is cosine over sine, so it's asking when is the cosine equal to 0 and the sine equal to 1 or negative 1, and that can happen at pi over 2 and 3 pi over 2. So that solves this. When I look at this side, I'm going to have to isolate the cosine on one side by itself, so I'm going to add 2 to both sides. So I'm going to say cosine squared x is equal to 2. Then I'm going to take the square root of both sides, so the square root of this side, square root of this side, and I'm going to have the cosine of x is equal to plus or minus the square root of 2. And I look at my unit circle, and I don't see square root of 2. I see square root of 2 over 2, but that's not this. If I were to do a quick check on my calculator, the square root of 2 ends up equaling approximately 1.4 something, not really quite sure, something like that. This is more than 1, which means this never happens. The cosine can never equal the square root of 2. This is not possible, which means from this side of the equation, I don't get any zeros. So my only zeros, my only solutions are going to be these two numbers here. Going back up, it wants all solutions. So I'm going to have to take and add that 2n pi. Write the two answers, add plus 2n pi at the end. Okay, the next one. Now that one had two trig functions, but I didn't have to replace because I was able to make them two factors, and then set each of those factors equal to 0. The next one, I have 3 secant squared x minus 2 tangent squared x minus 4 is equal to 0. There is no way that I can make these times each other, so I'm going to have to do some type of substitution. So I'm more comfortable with tangent, so I'm going to go with the tangent. I'm going to try and rewrite secant in terms of tangent, which means I have to go back to my Pythagorean identities, which hopefully one day I will have memorized. And I know that 1 plus the tangent squared x, I hate it when it's that thick, is equal to secant squared x. That's one of my Pythagorean identities. So in place of secant squared x, I'm going to write 1 plus tangent squared x. So in place of this, I'm going to write 1 plus tangent squared x. So that's going to be a lot of work, but we can do it. So here we go. I'm going to put the 3 outside. Whoopsie. 3 outside. It has a mind of its own right now. So 3, and then in place of that secant, I'm writing 1 plus tangent squared x minus, and then everything else I'm copying down, 2 tangent squared x minus 4 is equal to 0. Distributing my 3, 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 is equal to 0. Combining my like terms, I have the tangent squareds, yes, and I have the 3 and the negative 4, so I'm combining those like terms. If I can get my pen back. So when I do that, I'm going to have tangent squared x, just one of them, and then minus 1 is equal to 0. Add 1 to both sides, so the tangent squared x is equal to 1. Now I'm going to take the square root of both sides, square root. So this is the tangent of x is equal to plus or minus, and the square root of 1 is 1. When is the tangent equal to 1 or negative 1? That's when my denominator is equal to 4. So that's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if you're wondering why I wrote them that way, these are the two where they're positive. These are the two where they're negative. So since it wants all the solutions, I'm listing all those answers. Doesn't matter the order. Then I'm going to write plus 2n pi to show them taking multiple laps around the unit circle. Okay, here's one more. Pause the video, give yourself a chance, and try and do this one. You are definitely going to have to substitute. It should be interesting. Some of you may replace the sine squared with cosine squared. Some of you may replace the cosine squared with sine squared. Does not matter. You'll all get the same answers at the very end. So pause this video and see how it goes. Okay, hopefully you had success doing that. Let's look at it. So I did it both ways. I'm going to talk about the left side first. So on the left side, what I did is I decided to replace sine squared with 1 minus cosine squared. So this sine squared, I replaced with 1 minus cosine squared. I added cosine squared to both sides and got 1 is equal to 4 cosine squared x. Divided both sides by 4 to get, divided both sides by 4 to get 1/4. Then took the square root, got cosine of x is equal to plus or minus 1/2. And then the reason why I wrote it this way is because here are the places where the sine of x So I have cosine of x is equal to plus or minus 1/2. The reason why I wrote them this way is because these first two are the place where the cosine is equal to a positive 1/2. Here's when the cosine is equal to a negative 1/2. Again, it doesn't matter the order that I write them in. This other one, what I did for the other side, depending on how you did it, because you could do it either way, is this one I decided to replace instead of using, I replaced cosine squared with 1 minus sine squared. So in place of this cosine squared, I wrote 1 minus sine squared. This one might seem a little bit more difficult. They're basically about the same. I distributed I had to distribute the 3 and got 3 minus 3 sine squared x. Added the negative 3 sine squared x to both sides to make it 4 sine squared x is equal to 3. Divided both sides by 4. Sine squared x is equal to 3/4. Taking the square root, taking the square root. The square root of 3 is the square root of 3. Square root of 4 is 2, plus or minus. And then when I ask myself, when is the sign equal to plus or minus the square root of 3/2, I end up with the exact same answers that I ended up over here. So it does not matter how you did it. You're still going to get the same answers. This question just asked for the interval from 0 to 2 pi. So I just have to write those. So again, you only need one set of work. It does not matter which way. You get the same exact answers. So your homework, if you look at the bottom of your note sheet here, your homework is going to be this 5.3 worksheet. The answers should be online. If you have any questions, email me, and I hope you have a great day. Thank you.